All right, explore number 3. How can motion be represented graphically? Go ahead and write that out. Okay. And okay, hit pause. Take a moment just to write down what you think about that. And we'll jump into it, okay? So, how do you represent motion graphically? There's a couple things you can represent. The first thing that you see in the text is position versus time. Time is on the x-axis down here, right? This is your x-axis. And your position here, your distance, position is on the y-axis, right? So we'll say position versus time. Okay. And if you happen to be just kind of curious, you could kind of scroll down and okay, we're given a sample problem on position versus time. And then we have graphing velocity versus time. Okay. And we're just got some problems there. And that's it. Looks like we're going to be talking about position versus time. And it looks like we'll be talking about velocity versus time. Okay. So what do we want to say here? In this case, position can be represented as distance. Is plotted on the y-axis. Time is plotted on the x-axis. You should pay attention to the units here, right? Meters for your distance and seconds for your time. Keeping in line with the metric system, right? Okay. If you take a look at this graph for just a moment, you could kind of get a sense of the travel here. Let's clear our screen. Hopefully you can see it as well. From the first 2 seconds, was there any distance traveled? No distance traveled, right? No distance traveled, right? You could say that the object was at rest, therefore at rest. Okay. Up here as well, when it gets to a distance of 10 meters for from seconds number 6, 7, and 8, again, there is a point where there's no distance change. No change in distance, right? Therefore, the object here is at rest. Okay. Now, if we go with some different colors here, let's go with this one here. Now, from 2 seconds all the way up to 6 seconds here, right, we have a straight line. Okay, this straight line okay, it has a slope, and we could calculate that slope to get an idea of let's go and write this down here, the slope in here. Remember that the slope is your change in y. It's your rise. You've learned in math, your rise over your run. And that is like saying the change in y over the change in x, right? Which you could say is the same thing as saying y final versus y initial over x final minus x initial, right? Okay. And let's go ahead and, I'm sorry about that, but what would that slope actually give us? This slope,
Yeah.
the slope here would, if you're talking about distance over time, would you be talking about your average speed, right? Your average speed. That's what your slope would be in this particular case here, right? Okay. And as you can see here, your average velocity, or speed, velocity with change, is your change in x, that is your change in distance, over your change in time. Okay, so that was the slope, which we said was the change in y over the change in x. And what was y? That was the change in distance, right? Y-axis was distance. So that's the change in distance over the change in time, right? So you could say that it was your position final minus your position initial over your time final minus your time initial. Okay, and they show you with some numbers actually plugged in there. Okay. Okay. And they just go in to explain that. I think probably this would be an important thing. Notice that if we go back up here, they talk about what's happening here at the 8-second mark. At the 8-second mark, you have a negative slope. Negative slope. Okay. What does that mean exactly, to have a negative slope? Well, they go on to talk about that, where they say the change in position is negative, right? See, at the 8-second mark, the position begins to decrease. So the object is moving backward towards its starting position. Okay. right? And they go on to expand upon that. You see in yellow here, the minus sign indicates that the object is moving backwards, not that it is slowing down. In physics, the negative sign for displacement or velocity in one dimension indicates direction. Okay. So maybe what we can make a little note for ourselves here. A negative sign, right, indicates that the object is moving backwards. Okay. And not, no, it does not signify a slowdown. It does not signify that, okay? All right. Now, if you have a straight line, okay, so let's just kind of say here in the example, if you have something that was increasing, then it decreases going down, right? Then that's what we're referring to, is this part right here. Okay, negative slope. Okay. Now, how do you figure out instantaneous velocity? If we wanted to know at this point right here, what is the instantaneous velocity? Okay, at, let's just say that this was at, that was at 2 seconds in time, right? If this is time, and we said this is 1, and this was 2, and this was in seconds, right? Time. If we want to know exactly what that was, because this is a straight line, because it is part of a straight line, it'll have the same value as the slope of that line. Because it is part of a straight line, the slope represents both the average and the instantaneous velocities. Okay. Okay. And you're going to get into a few more problems, and then you're going to get into the next thing, Roman numeral 2. And this is going to be graphing velocity versus time. Okay, so if you take a look on the y-axis, there's your velocity. This is the y-axis, right? This is your y-axis. And then you have your x-axis, right? and time is located on your x-axis, okay? And so graphing velocity versus time instead of distance. So what does it say up in top here? It says the motion of an object can be described by a graph of its velocity. Over time, the velocity is plotted as a dependent y-axis. Okay, yeah, we got that. That's all pretty basic. Let's move on a little bit. In the first 2 seconds, the object's velocity is 0. This means the object is not moving. From 2 to 6, it's got a velocity of 2.5 meters per second. And then from 6 to 8, the velocity is 0. And that's at rest. And then the object is moving backwards with a negative velocity of negative 5 meters per second. All right. So maybe we want to write some notes here. This space in here is at rest, as is this section right here at rest, right? Now, from maybe that's not really the best way to say that. I'm sorry about that. Let's actually take our eraser and let's do that. Okay, so we have this is at rest and this is at rest. I'm sorry about that. And the reason why is because we're looking at this value right here, 0, right? So these are at rest. Okay. Now, what about, let's take these colors here, and from 2 seconds through 6 seconds here, the velocity is 2.5 meters per second. From 2, right, from 2 to 6, right, because that 2 is up there and that 6 is up there. So from 2 to 6 seconds, it's traveling at 2.5 meters per second. And then from seconds 8 to 10, it's actually got a negative 5. And what does that negative 5 signify? It actually signifies that the object is what? Moving backwards. Okay. Okay, so graphing velocity over time. Here's another graph, velocity over time. In the following velocity versus time graph, the velocity increases gradually. This is still a straight line. It is gradual. This is a line. Therefore, you could figure out the slope equals rise over run equals the change in y over the change in x, right? All right, so whenever you see some of these things, you can take these basic math principles and you can use them to help interpret your data in science, okay? The slope of the velocity versus time graph is the acceleration. That is actually maybe really important to know, okay? The slope represents acceleration. Okay, and remember, acceleration is a change in velocity over a change in time. Okay. Change in velocity over time. Okay. Okay. The area, now this is interesting down here. The area between the curve and the horizontal axis on a velocity versus time graph also has significance. So what they're talking about now is they're talking about the area under the curve. These areas have significance. Okay. Okay. Let's go back and read that a little bit. The area between the curve and the horizontal axis has significance. It demonstrates that the area under the velocity versus time graph between two moments in time is the displacement of the object during that time. So what does this represent? The area represents displacement. Okay, represents displacement. Sorry about that. Okay. So we can write that over here. Where's that at? Where were we writing that there? Okay. Looks like area under the curve. Under the curve represents displacement. Okay. A lot of concepts, huh? In fact, this is always true for every time interval on a velocity versus time graph. Okay, so that's a good rule to remember there. Okay, and are we almost finished here? Look at that, we are. All right, so I think we'll go ahead and leave it at that. Okay, make sure you're doing the reading. Okay, take time to understand these ideas. And let's go and write ourselves a summary. Okay. All right. Talk to you later.